Alright, so what we're going to do here is we're going to implement jump buffering, also known as jump queuing. In Godot, in 2D and 3D, it's Godot 4, and we're going to be using a RayCast, not a timer like most of the other tutorials seem to do. A timer doesn't seem right. If you think about things like platforms with different elevations, I just honestly don't see how a timer makes sense there. So I thought, hey, I'll implement it with a RayCast, which I was unable to find a video tutorial on for Godot 4 specifically, or at all even. So yeah, that's what we're going to do. This should work with the Jolt or the Godot physics engine. As you probably know, since Godot 4.6, you start a new project, it's going to default to Jolt. Older versions of Godot 4 are going to use Godot physics. Yeah, this just dealing with mostly boilerplate code, so shouldn't be a big deal either way. And if you're adding it to an existing project, this should apply equally as well there too. Um, I just figure I'll do the most simplest implementation and not get sidetracked. So your numbers may vary based on what I have. I have mine set to 320 by 180 for the actual pixel resolution for the 2D, and for it's going to be upscaled a little bit. Sorry my screen looks so zoomed in, but hopefully that at least allows you to see it, and maybe it allows me to drop less frames while I'm recording, which should be the case because when I hit record earlier, I was up close to 100% of CPU utilization, and this looks like it's less than 50, so we're off to a good start. Okay, that being said, everything essential should still fit in this screen, and again, I'm going to be doing it in both 2D and 3D. We'll start with 2D. I will get rid of this little RayCast that I forgot to get from earlier attempts at this. We'll go back over here to the 2D scene. We'll briefly explain what we got going on. Just empty scene, obviously. We got a collision shape right here to act as the world boundary. This represents our character, and in my case, I'm going to turn on visible collision shapes. You don't have to, but that's just so I can avoid actually attaching a sprite or anything fancy like that, and we can just work with this as is. Of course, we got a collision shape right there, so that's what we're seeing. And if I were to hit play right now, nothing would happen. So, of course, we need to attach a script to this character body 2D, and I'm going to go ahead and attach the default character body 2D script, the Godot, the boilerplate one. And again, this should work equally well if you have your own. In which case, this one's using physics process, it could be in process or whatever, wherever you're handling. This is the velocity Y up down effectively, and this is the left right X, but we're just going to be messing with the Y, of course, the up down, the jump. And if we look here, if not is on floor. So what's that? That's saying if they're in the air. And then this one, if this and is on floor. So this one's saying effectively on ground. Well, here's the deal. If we already tested for whether or not there is on floor, of course we put the not here, or they did, because in the case that they're not on the floor, they want to handle this. Of course we can come down here and just say else if, and we don't need to test if it's on the floor again, because by including this little else part, we're saying, well, if they're not on the floor, then do that. Else, they are on the floor, and check if they press the jump button, and then jump, right? So that's what's going on there. So what I changed makes this behave exactly the same way, 99.999%, as what it just was. It just has one less redundant test there. So I'm going to hit play, and go ahead and select this current scene to play. And once that's all fired up, we can see here, got the nice floaty default physics going on. So when the character's on the floor, jump, and of course not double jumping when it's not on the floor. And what we want to do is we want to make this jump feel fair. So like when I'm going to try and time the jump, like see how sometimes it's sticking, you can hear me hitting that space bar. So that's not very fair if it does that. What I can do though to make this a little more realistic is jump over here in the project settings if it doesn't crash everything, and I'll go to the 2D physics and I'll crank up the gravity to about 4,000 pixels per second. And of course, your mileage may vary here, so just crank it up to whatever you got to do to get that tight jump. And then if I restart it here, oh, gotta click back in here. See, I got a really tight jump. It's pulling me back down to the ground really quick. So that's a little bit nicer, more real world of a feel. So I'll jump over here, and I'm gonna also give me some power to get away from the ground a little more effectively. Restart it. And see, can't hover over that stuff. All right. So now it's kind of almost back to where it was, but it's pulling me back to the ground. So a little bit more real world to a game, but I don't have hang time and I don't have variable height jumping. So that being said, it's real easy to like start timing my jumps in my subconscious while I'm testing it, see how it's never sticking. So I want to do something to change it up so it's sticking by, if you can hear me, I'm pushing it. Sometimes I hit the spacebar and it doesn't jump because I'm distracting myself from my mind and movements here. So we want it to basically jump if I was really close. That, of course, is the effect we're going for. So I'll stop that. And what we need to do then is add a RayCast 2D, since we're still in 2D right now. And I'll go in here and add a child node. And I'll just punch in RayCast up here. And there's RayCast 2D. I can double click on that. And now we have one. And it went ahead and parented it to the scene tree for us, which I believe is a feature, not a bug. Because if we come over here, then it's way up here. And that allows us to move it. Because otherwise, if it was parented to this and I tried to move it, this would move away from it. So this allows us to move it here. And I can just do something like that. And then we can shorten it up here. And we'll see if that is good enough to make it feel fair. And then we'll want to make sure and reparent it to the character body there. And that being done, let's check it out. This isn't going to give us the effect just yet. It will just show us like a signal of whether or not, it'll just show us the RayCast really, and that's about it. So if I jump, the RayCast turns red. You can barely see it poking off the bottom of the screen there. But it should be I'm still sticking to the ground because I'm getting excited and jumping too soon. I'm going to pull this thing up just a little bit here so we can see the RayCast a little better. And what we'll do now is add the code for the RayCast. So if we just drop the RayCast there, it's just going to put the RayCast in, and it's going to complain, and it's like, hey, what are you doing just dropping the RayCast node in there without all the official stuff? So if we hold it, about to drag and drop it, right before I let go of the mouse button, I'm going to hold down control and then let go. And that gives us all the extra stuff we need. There's the original thing. There's the type, because this just brings it in as a regular old like node 2D or whatever. And tighten that name up a little bit there. Save it. I like it like that. Okay. And now we have the RayCast. We have access to it in our script. So now we need to actually use it. So if we're in the air, then of course we want it, that's if not is on floor is the same thing. And then if they're not on the floor, we always want the gravity to bring them down, which is what it's doing there. But we also want to check that if they press the button while they're in there, they press the jump button, and the RayCast dot is colliding. So if they press that jump button and the RayCast is colliding, both of those conditions are true, then that means they're in this situation, because remember this is the ground right here. So if they're in the air and they're coming down, they haven't touched the ground, but the RayCast is colliding, then we know we want to go ahead and give them the jump subtly. They think they have it because our timing gets off in our head, right? Okay, so we'll say has buffered jump, and we'll set it to true. Well, of course, we need to declare that variable because we can't just start using it like in Python or something. So we'll declare it up here, and we'll have a default to false. By default, they don't have a buffer jump. And this sort of wording is like, you could say is jump buffered or something. That's for true false Boolean values. You just want to word it something along those lines usually to make your code nice and readable. So if they press jump effectively, that's not my unreadable code. That's the way Godot does it. And RayCast is colliding, which also is Godot, but they did it readable that way. Then has buffer jump equals true. So we're going to give them that jump. But the problem is we're not doing anything with it yet, right? So it's not much better than it was. So down here, if they're on the ground and they press jump, then they can jump. Or we want to check if has buffered jump. So if has buffered jump or they press jump, then we'll give them the jump, right? So in this case, I put this one, you could put this one at the end too, like this, but with the or if you wanted to, but I put it right here because then it's a little more logical, makes sense just for us reading the code. Because if we're not going to check if the jump button's pressed, really, we're going to short circuit on this one. If they already have the jump, it's like, hey, we're not worried, we're going to give it to you. We have already decided we're going to give it to you. So in that case, we need to set this to false, so that it doesn't just keep on jumping. You can try it out, and it will just keep on jumping as soon as they ever buffer one jump. So there we have it. We have our default is false. Then we set it to true when the RayCast is colliding and they're in air. And of course, you may want in a more complex game to add more nuance there of what it's colliding with or collision layers, all that good stuff. But we're just going to keep it simple for now. Then we'll give them that jump. And then if we come in here and they have one of those jumps, we'll reset it to false and give them the jump. Or if they're running around on the ground and they didn't have a buffer jump, then eventually whenever they push jump, they'll just get it anyway, like usual. So that's it. That's all there is to creating a buffer jump with a RayCast, at least in 2D. 3D is almost identical. But actually, you might need to fine tune the RayCast length. So that's something you want to come back. We can see it's colliding there. It turns red. So you'll want to do some bouncing around and see if it feels fair. You don't want it to feel too cheaty, and you also don't want it to be like no matter what, like if they like, see how it's not giving it to me there, we want that effect. We don't want it to give them a jump if they're at the peak of the jump, but if they're coming down, let's see if we can get it not to work. Wow, it's hard to get it not to work, but it does. That feels pretty fair to me, so I'll just leave it like that and move on to the 3D. So we'll close out the 2D scene. We'll switch over to 3D. I'm going to delete the 2D code since we're done with that. And we'll load up a little boilerplate 3D scene I have. Maybe. Okay, there it is. And we need to add a character here. So this is boilerplate. I added some, I brought the world environment and directional light in. I brought a camera in. Now that I think about the directional light, it's still on the ground. We'll bring that up a little bit. And yeah, we got a camera so we can see what's going on. We got a CSG box as a temporary platform to be able to collide with. In my case, I set it to an albedo color on the create a new material or whatever. And then I made sure somewhere around there to turn on collision. There it is. Use collision on. And yeah, so we'll go to scene 3D. We'll add a child node. We're going to go ahead and add a character body 3D this time. And we'll add a collision shape to that. Probably should have this stuff already done. And then to that collision shape, we'll go ahead and add a capsule. And then since it's 3D and it's easy to do, we'll go ahead and just add a mesh instance 3D with it also as a capsule so that it doesn't look like this hard to see wireframe. We can see the whole capsule mesh. And I'm going to click back on the character body 3D little parent thing there and bring it up. so we can see the whole thing. And I'll go ahead and group those nodes together so that they all tend to move as one unit. And yeah, so that's that, and that won't move unless we attach a script to it like before. So again, I'll attach the boilerplate basic movement 3D script to it, which is very, very similar, other than it's meters per second instead of pixels per second for this kind of stuff. But yeah, this code right here I think is identical. This one's a little different, right? Yeah, that's 3D. Okay, so again, just going to plow through the same thing. So it's almost just repetition on the first thing, and also just demonstrating that it works in 3D. So what we're going to do is hit play and see what it's like by default. And it's by default, it's still 2D. So I need to go reset that over here. I'm going to go to run under application, and I'm just going to reset that and close. And then it's going to ask me which scene I want to play. And by selecting current, it will be the 3D scene over here. If I hit play scene, I don't use play scene very much. So if I tell myself like, oh, I'll just do it like that, then I'll just forget to do it like that, like every single time. Okay, so we got our basic movement. And I'm going to leave this one on floaty because it's, even though it's less representative of maybe how our real world game would be, we can actually like do that on purpose and get that effect and see it really working in effect. For 3D, instead of going left and right, I feel like going back and forth is a little bit more representative of like whether or not the jump's fair, or otherwise, if you have a real tight jump, go in circles while you're doing it and just try and like, you know, get a little bit distracted there, and you might be able to determine whether or not you're sticking, or it feels like you're sticking unfairly. Okay, so again, same thing. Gonna add the RayCast, add child node, and then I'll just type in Ray, and this time RayCast 3D. And the RayCast, let's go over here so we can see what's going on. So you can see it's way down here, and again, it's not parented. So if I bring it up and we zoom in, you can see this color. So one thing to note here, I'm going to go ahead and bring the character body up a little bit here so we can really see what's going on. There's like this infinite green line on the y-axis coming out of the character. I guess, could I move it? Okay, duh. I should have done that before. I wasn't moving it off that line, and I was like stressing on that. Okay, but you didn't see that, so you don't know. Alright, so yeah, this is our actual RayCast here. So you can either, even if you did want to keep it on the line, the RayCast is a different color. So it's you can tell it apart, but it's just not quite as easy as it seems like it should be. So I'm going to click on RayCast, then come over here, and we can see, we've got to remember, especially in 3D, it's negative. So if I were to put +1, it disappears because it goes up into the body. Instead of coming out of here and going -1 down, it's going +1 up, because the origin is a relative origin right here instead of the XY, you know, 0, 0 and whatnot. Okay, so if we, again, I'll create -0.5. So I'll give us this little stubby one here. And if you don't like that color against your background, I don't feel like that's the best one. You can come down to debug shape and set it to like sort of a hot pink color. I think works pretty well. And then remember to reparent this to character body. So yeah, that's the way it's got to be, so it moves with the character and all that. And also it won't detect collisions with its parent by default. See, exclude parent is what that's saying right there. So we want to exclude parent by default. We just want to collide with the ground. Alright, any minute now maybe. Alright, there we go. So there we can see our, it's a little bit off centered, probably doesn't even matter to tell you the truth, as long as it's like roughly right there. But the thing is also, it's not working, it's just there at this point, so we still have to hook it up in code like we did last time. So I'm going to, if I ungroup the nodes for a second and kind of do one of these and get straight on with this axis here. Okay, there's the one. See, I'm a little off-centered, so I can tug it that way, and I have the use snap on there. So yeah, that I'll save that, and then if we look, that's a little better centered. So let's go ahead and test that out. So there it is. It's a little more centered, but still not activated. So I'm going to stop it, and I will come in here and get to work. So again, I'm going to drag and drop, and I'm going to hold control while I drop. While I release that mouse button, I'm going to tighten up this variable name here to something I like a little better. And again, this one is in air, just like before, and this one is on ground. You don't have to do that, but I just prefer to. And to be able to get rid of that redundant test over here of is on floor, I switch that to an else if clause right there. So if not on floor, then pull the player towards the floor. Else, if they're on the floor, which they are, then press the jump button. They are if they enter this case, and don't press the jump button. I should say, are they pressing the jump? Else they are on the ground. If they're pressing the jump button while on ground, then give them their jump. Something more to that effect, right? Okay, anyway, we want to go ahead and make that variable again, has buffered jump. We'll set it again to default to false, and then we'll come down here, and as usual, if they're not on the floor, we're going to pull them to the floor like it does by default, and we also want to redundantly, so to speak, check if they're pressing the jump button. But we don't care if they're pressing the jump button unless they're also intersecting with the floor. So if it's way down there like that, right, and intersecting with the floor, that's when we care. You don't have to do that in the 3D editor. I was just demonstrating it. So if they're pressing the jump button and RayCast dot is colliding, then if you remember, it is oops, this one. Bring this back over here where we can see. Maybe I should just widen it out. So yeah, the has buffer jump, we're going to set to true. We're going to give them one. So default, they have none. If it meets those two conditions again, we're going to set it to true. And then we're going to come over here and spend it and say, okay, when they're on the ground, if they have that buffer jump, or I don't know why I did that, or the input action is just pressed. So if either one of those cases is true, then they get another jump. But first it's going to check if they already had one, because then it doesn't matter there. Alright, so, and of course we need to remember to set it back to false right away so it doesn't just keep bouncing like a bunny. And we'll just do that right away. So that's that. That should be all there is to it. I'll hit play. And if Godot will just not crash one more time. So we can see if the spike hits. But if I hit it before the spike, it doesn't. So it just feels a little more fair. And again, you may need to adjust it to be longer or shorter depending on your exact needs. But that's all there is to it. That's how you create a buffered jump or jump queuing in Godot 4. Thanks for watching.